Alright, pre-calc, so 2.2 part 1. 2.2 is going to be all about quadratic functions. We're going to look at a couple different forms. We'll talk about vertex form, and then the next section or the next lesson will be in what's called general or standard form. Okay, so we're going to look at the graphs of quadratics. We'll identify some important characteristics of their vertex form, and then we'll use that information to actually draw a graph of a quadratic. So, first thing, the graph of a quadratic function, don't forget, is a parabola. And what determines if we open up or down, now that is the value of a, which, remember, a quadratic has a leading term or leading coefficient of a. So if it opens up, a is going to be greater than 0. If it opens down, a is going to be less than 0. So if the graph opens up, then its vertex is going to be called the minimum. And if you think about that, remember the graph is going to be some parabola like that, which makes sense then because our vertex will be our lowest point. And then the converse of that is if it opens down, then the vertex is the maximum, which makes sense. If you think about your graph again, it's going to open down like that, going off to infinity each direction, and then our vertex would be the maximum, or the highest point. And so there's a couple key points. The vertex form then is going to be f of x or y equals a x minus h squared. This squared piece here is very important. Remember, that's what makes it a quadratic, plus k. And so your vertex from that will be hk. Now I know a lot of people in the past, we have said that h hates the sign. So when we're dealing with x, this has got to be the opposite sign, and k keeps the sign. So k, here our y value, has the same sign. So if it's plus some number, k is positive. If it's minus some number, k is negative. Conversely, again, if h is subtracting some number, h is going to be a positive number, and if x plus some number, then h would be a negative value. Now the axis of symmetry is always that imaginary dotted line that goes right down through the vertex. It's going to be a vertical line, so it's always going to have the equation x equals h. So it's important that we write this as some number. We don't want to write just the number. We need to write the equation, which means x equals whatever that number is. Okay, so a couple practice problems here. If I wanted to find the vertex for this, okay, the vertex in this case would be 2, 12. And my axis of symmetry would be x equals 2. And the last thing, we could say that this one opens down because this value right here is negative. Okay, looking at the second example now, our vertex is negative 1 and then positive 5. So our axis of symmetry would be x equals negative 1. And again, this one opens down because we have a negative a value. Okay, to graph a quadratic in vertex form, like we just saw, you're just going to determine if it opens up or down first. And remember, that has to do with if a is greater than 0 or a is less than 0. Then we're going to determine our vertex, and those have the coordinates h, k. We can use that also to get our axis of symmetry, don't forget. So you could even add here the axis of symmetry, x equals h. And then we're going to solve f of x equals 0, which means set your vertex form equal to 0 and solve that. That's going to be, we're going to use in this form the square root property, which we did earlier in the year, and this is going to give us our x intercepts. Okay, now we could have 0, 1, or 2 x intercepts. Next, then we're going to set 0 in for x, so that means change all of your x's to 0 and simplify, and this is going to give you your y-intercepts. Now for this, there should only be 1, and there should always be 1. And then finally, so you'll have your vertex, 0, 1, or 2 x-intercepts, 1 y-intercept, and then you can plot the vertex intercepts and draw your graph. You can also do what's called a point or points of symmetry, in particular with your y-intercept. So if we've got our axis of symmetry drawn, remember, anything that happens to the left has to happen symmetrically on the right, or vice versa. And so an example of what that would look like, I'm going to start, I know since there's no value in front here, this is 1, so I know this one is going to open up, which means my vertex is my lowest point. My vertex is going to be 1, negative 2. So I'm going to plot that point, 1, negative 2. There's my vertex. And then I'm going to say f of x equals 0. So I'm going to plug in 0. I'm going to plug in 0 here. and I get x minus 1 squared minus 2, and I'm going to solve this for x. So I'm going to start by adding 2 to both sides, x minus 1 squared, and then I'm going to square root both sides. So this is going to give me plus or minus the square root of 2, which is about 1.41, and that will equal x minus 1. So then I'm going to add 1 to both sides. So I get x is about 2.41 and negative 0.41. So those are my two x-intercepts. I can plot those. So about 2.41, right around 2.5, and then negative 0.41, so right around negative 0.5. And then finally I'm going to do my y-intercept, which means I'm going to plug in 0 for x. So if I pull this down, I plug in 0 for x, I have 0 minus 1 squared minus 2. Which is going to give me, if I simplify this whole piece, I end up with just 1, because 0 minus 1 is negative 1, negative 1 squared is 1, minus 2, and so I get negative 1, which means my y-intercept is 0, negative 1. And so I can plot that point at 0, negative 1. Okay, since my axis of symmetry goes right up through the vertex, I could also do a point of symmetry, which would be right here, because I am 1 unit to the left, I could go 1 unit to the right. And then finally, the last thing we're going to do then is draw a nice smooth curve for our parabola, going off in both directions. Okay, and that would be the graph of our parabola. Okay, so challenge problem, you can turn this in on a half sheet of paper at the beginning of the next class section. Each parabola in standard form, really, that should not say standard form, that should say vertex form. So you're going to take this information, we have our vertex, and what you are missing is A. And so that's how you're going to use your second point. Think about what we have here in terms of what those coordinates give us, like an x and a y, and you could try to solve for A and create your equation. Okay, so you can try that for bonus points starting at the beginning of the class next time I see you. And other than that, that is it. Vertex form, remember, just gives us some basic information. It tells us what our vertex is. We're going to find our x-intercepts by setting the equation equal to 0, solving for x. You're going to find your y-intercepts by plugging in 0 for x and solving or simplifying for y. And then we can put all that information on the graph to finish our parabola. Okay, we'll see you next time, guys.